So why is scientific notation important when we're doing chemistry? It's because in chemistry, we are dealing with incredibly small things, specifically atoms and molecules, right? Super tiny. They're floating around in the air all around us. We can't see them because they're so incredibly small. So if we have a container, maybe a graduated cylinder that's full of water, that graduated cylinder is full of water molecules. There are a lot of them. And if we wanted to get an understanding of how many water molecules are roughly in, say, 50 milliliters of water, well, that's a really big number. And that would be really hard to represent in standard form or in decimal notation like we're used to writing numbers. So scientific notation helps us with that. Scientific notation allows us to write extremely large numbers or extremely small numbers in a very concise way. And as an example, we just want to start off with using a value that we actually use this in chemistry some, but it's the speed of light. Now, the speed of light is roughly, there's my little, approximately 3 times 10 to the 8th meters per second. All right, so that's what scientific notation looks like. You should remember that from Algebra 1. You should have used it in there. And what does this mean? Well, literally, you are saying it's 3 times 10 to the 8th power. What is 10 to the 8th power? Well, the 10 to the 8th power is a 1 with 8 zeros after it. So 1, 2, 3, 4, 5, 6, 7, 8, right? So it's this. It's 100 million. And so 3 times 10 to the 8th says it's 3 times this 100 million. And so what is that? If we do the math with it, we're going to get 3 with 8 zeros after it. 1, 2, 3, 4, 5, 6, 7, 8. Again, 300 million, right? And so that's literally all it is. This is 10 to the 8th, so it's a 1 with 8 zeros right here, right? 8 zeros. And if we want to go from scientific notation 3 times 10 to the 8th and to standard notation or decimal notation, we could just literally multiply. Say, what is 10 times 10 to the 8th power? That's 100 million. Multiply that times 3, we get 300 million, and we're done. We've converted from one to the other. Or you can use this little trick, right? If you have with 3 times 10 to the 8th, there's an understood decimal after this 3 here, right? If we wrote 3 without the decimal, it's the same value as 3.00, right? You could write 3 with or without a decimal. Well, what you want to do if you want to convert from scientific notation, if it's a positive integer, here in the power the exponent on the 10 there, if it's a positive exponent, you're going to want to move this decimal place here 8 places to the right because there's an 8 up here. And so if we do that, we're going to take the decimal place and we're going to move it here. 1, 2, 3, 4, 5, 6, 7, 8. We're going to move it over 8 places and we're going to pad all of those 8 places with zeros. So 1, 2, 3, 4, 5, 6, 7, 8. And our decimal comes over here now. So we have to remove the initial decimal, right? And so we can then quickly say that 3 times 10 to the 8th is 3 with moving our decimal place over 1, 2, 3, 4, 5, 6, 7, 8. We can quickly convert from the scientific notation to the decimal notation by doing that. Now, if we want to do the reverse, in other words, if we want to go from decimal notation back to scientific notation, then we just simply say we take the decimal place, the understood decimal place that's here, and we're going to hop 8 places. We're going to hop to the left until we get to just after the number that's in the very front. If you remember, scientific notation is always represented that way. Like you could have a single number, like 1 times 10 to the 9th. That's scientific notation. But you could have, if you had other numbers in there besides the 1, like let's say it's 1, 2, 3, and then maybe a 0 at the end if you wanted to put it on there. You always have a single digit here followed by a decimal place when you're in scientific notation. So 1.230 times 10 to the 11th would be the correct way to write something in scientific notation. So let's practice this since I've written it out. How would I convert this to decimal notation from scientific notation? Well, I would take this decimal here and I have to move it 11 places to the right, right? So I'm just going to take 1, 2, 3, 0. I'm just going to pad it with a bunch of zeros. See how many we need. The decimal was here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Need a couple more zeros, 10, 11, right? That puts our, moves our decimal all the way 11 spaces to the right. And so this value here would be, having trouble circling that, would be, or putting a box around that, would be this scientific notation number represented in standard form or in decimal notation. All right. What if we want to go in the reverse? What if we want to say, we want to convert from, I don't know. Let me erase some of this so we can have a little more room to work with. Let's say we want to go from, did I write down an example for this? We want to go from, let's just make one up. I don't see one. Here we go. We want to go from 230 billion, 450 million. We want to convert from this to scientific notation. What would this be in scientific notation? Well, this time we've got an understood decimal place at the very end of this, and we need to back that decimal place up until it is right here, just after the 2, right? You always want to have that single number in the front followed by the decimal place when you're in scientific notation. So how many places do we have to hop to get back over there? We got to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have to hop hop over 11 digits to get back to that decimal spot that's just to the right of the 2. So that means if we want to write this in scientific notation, we would do 2.3045. We typically don't write any trailing zeros that are after the decimal place there. And since we had to hop over 11 places, then that's going to be 2.3045 times 10 to the 11th. All right. Now, what about numbers that are smaller than 1? If you have numbers that are smaller than 1 that you want to represent in scientific notation, then you're going to have a negative exponent on the 10. So for example, if I had 3.3 times 10 to the negative 7, what that would be in decimal notation would be 0.00000033. All right. And where I got that was I took this decimal place here, and because this is a negative 7, I had to move it 7 places to the left. So the decimal place was here in between the 2 3s, and I went 1, 2, 3, 4, 5, 6, 7 and put the decimal place there because this is a negative 7. So the negative tells me that I've got to go to the left whenever I hop over from the current decimal location. And if it's a negative exponent, that number is always going to be less than 1. What you're literally doing here is you're taking this 3.3 and you're multiplying it times 10 raised to the negative 7 power. Well, what is that? I don't know if you remember this or not, but you learned in some of your earlier math classes that if you take this 10 to the negative 7 and you move it to the denominator, that becomes a positive 7. So 3.3, so we're really doing 3.3 times 1 over 10 to the 7th power, which means we're doing 3.3 times 1 over 1 with 7 zeros after it. 2, 3, 7 right there, right? So 1 over 10 million. And when you punch that in your calculator, you're going to get this number right here, right? But the quick way to do it is just hopping with the decimal place, like I said. Now, to go in the other direction, let's say we want to take a number that's given to us in decimal notation, and let's say we want to do, I don't know, let's do that. We know this number's less than 0, so we're going to have a negative exponent. So it's 0.0000895 0. Let's just say that. All right, that's how the number's presented to us. How do I turn this into scientific notation? Well, I've got to take this decimal place here. I got to take this decimal, and I need to move it just over the first, just to the right of the first non-zero digit, which is this 8 here. So I want to put the decimal place right here in between the 8 and the 9. All right. So let's move it over. 1, 2, 3, 4, 5, 6 places. So we moved it 6 places to the left, which means that this is equal to 8.950. I put the decimal place after the first non-zero digit. And since we had to move over 1, 2, 3, 4, 5, 6 places to get there, it's going to be times 10 to the negative 6. Okay? So that's how you go from decimal notation to scientific notation. Again, we're not going to use this a ton in chemistry, but we definitely run into it. And particularly when we have a problem that asks us like how many atoms or how many molecules are in this container here. And so if we have to count those values because they're so small, we're going to have a really big number. So we're going to have something to a positive 10 to a positive exponent. And then we've also got some constants that we have to use in chemistry that are presented to us in scientific notation because they're incredibly small or incredibly large, right? So we just need to be familiar with this concept, able to use it, and able to punch it into our calculator. So again, if you're struggling with this, if you're still confused about some of the concepts, I encourage you to go online and look for some other tutorials that walk through using scientific notation. It would be great as well if you look up some tutorials with your particular calculator, right? Whatever scientific calculator you're going to use for the class, make sure you know how to use scientific notation on your particular calculator because that's going to be critical so that you don't make mistakes on quizzes and tests, okay? All right, you have a great day.